Hello everyone, I am Ümit Alkuş. In this video, we will solve one problem in chapter 23. A spherical metal shell with inner radius A equal to 12 cm and outer radius B equal to 27 cm has been deposited a total charge Q2 which is -5 microcoulombs. A point charge Q1 which is 20 microcoulombs is placed at the center. A. Find the inner and outer surface charge densities. For symbolic calculations, let Q equals 5 microcoulombs, then Q1 becomes 4Q and Q2 becomes -Q. Let us remember the shell theorem, which states that in all electric field calculations of spherically uniform charge densities, you may treat all the charges of interest within a region as it were concentrated at the center of the sphere. For metals, there is no charge inside the metal and all the charges are distributed on the surface. Therefore, the electric field inside the metal is 0. Okay, let us solve the problem. Q1 is given as 4Q. Now, if we draw a Gaussian surface enclosing the inner surface of the metal, according to the shell theorem, the charge inside this metal is 0. Therefore, the charge on the inner surface becomes -4Q. Now, again, if we draw a Gaussian surface enclosing the outer surface, by the same way, there is no charge in the spherical shell. Therefore, all the charges are distributed on the outer surface. Total charge is -Q. Therefore, outer surface has the charge of 3Q. Surface charge density is found by the formula total charge over the area of the surface. Then, the inner surface charge density is found as -4Q over 4 pi a squared. Here 4's are cancelled. Then we are left with -Q over pi a squared. Now we can put the numerical values into this formula. As a result, we obtain -1.11 times 10 to -4 coulombs per meter squared. Similarly, the outer surface charge density, sigma O, has the form 3Q over 4 pi b squared. If we substitute the numerical values into this formula, we obtain the outer surface charge density as approximately 1.64 times 10 to -5 coulombs per meter squared. B. Find the magnitudes of the electric fields everywhere. In the first region, R is less than A, we have point-like charge 4Q. Therefore, the electric field is calculated as K times 4Q over R squared, or 4KQ over R squared. For the region where R is greater than A and less than B, that is inside the metal shell, electric field is 0. Because if we look at the inside, we don't see any charge there. Finally, in the region where R is greater than B, that is outside the whole sphere, we see only the charge on the outer surface, which is 3Q. Therefore, the electric field is calculated as 3KQ over R squared. C. Draw the electric field lines everywhere. In the first region, we have point-like charge 4Q. Therefore, the electric field lines is drawn radially outward. In the second region, that is inside the spherical shell, there is no electric field lines. Finally, in the third region, we have only 3Q, but according to the shell theorem, we consider this charge as if it is concentrated into the center. In other words, it behaves like a point particle. Therefore, we draw the electric field lines in the third region being perpendicular to the surface of the sphere. Okay, we are done. Thank you for your attention. See you in the next video.